Hello and good morning. First of all, let me wish you happy 25th anniversary. The next 25 years will be even more exciting for our industry. The central thesis of my talk today is our industry is in a unique position to create or shape the evolution of 5 networks that will be at the nexus of new value creation. What are these networks? Why do I believe that? How will that happen? That's going to be my talk. Let's take a step back and ask a more basic question. How does technology create economic value? We can lay out 5 expectations we have in this regard. First, productivity growth, doing more with less time, less effort, less resources. Consumer surplus. We pay less, get more. Sometimes even get some things for free. We expect technology to help us to live longer, live better, and do this not just for us, but for our future generations. How have we done so far? Mostly good, but we are having some problems. Let's start from the bottom. The previous industrial revolutions have indeed created some sustainability problems for us. Think pollution, climate change. Some of our tech is indeed causing quality of life headaches. Think about fake news in social media. Indeed, we are living longer, but there are lots of lives, young lives lost in things like auto accidents. And consumer surplus, we see that only in digital goods, news, web search, free calls, messages. But you go to grocery shopping or furniture or cars or buying homes, you don't get anything cheaper than before. And productivity. I think you will share my feeling that we are always working harder and always lacking in time. So we have some problems. Now, economists tell us that if there is one thing we should focus on, and that would be productivity. It's not everything, but in the long run, it's almost everything. We solve for productivity and we get bonus points on the other dimensions. Our costs go lower, prices go lower, more consumer surplus. We can find solutions to health problems early, longer life. We have more time, more leisure, better quality. And by using less resources, we'll be more sustainable. So productivity seems to be the holy grail for technology. But we have a problem. Our numbers tell us that we have productivity paradox. This chart from IMF tells the story about decline in productivity growth all over the world. But it's only part of the story. It's just going back to 1990. Let's take a deeper look. The chart that you're going to see here is US productivity since 1900 by decades. Industrial revolutions, first and second, big boom in productivity. Since then, productivity has been going down. And that's a problem. This book by Professor Gordon from Chicago University caused a lot of controversy. He claims that the best days of technology are behind us. Electricity and telephony, landline telephony in early years, made a big difference to society and economy. But since then, computers, mobile, internet have not made that much of a difference to productivity. Now, that's something that should worry us. There are some who are even more negative. They say that modern technology is creating more toys and distraction, and we are wasting time and resources rather than saving. Now, Professor Gordon's study is quite solid. very analytical, data-driven. We cannot ignore it. So we at Nokia Bell Labs were quite intrigued by this. If he is right, then we have no business. We are wasting our resources. Now, in his book, he does talk about some very concrete, specific examples and how they made a big difference. He talks about automobiles, refrigeration, but he also talks about some business model innovations. He talks about consumer credit. People could buy appliances at home that help them improve their productivity without paying all the money in front, and paying it over time. Why did that matter? Because it increased the diffusion of technology. Technology spread faster, and that was a key insight. Economists care about diffusion of technologies, innovations, how they spread in the society and how fast they spread in society. So it turns out that there are some technology innovations which are like networks are even more important because they're catalysts. They increase the speed of adoption of other technologies. So we dug deeper. We collected data on these networks, landline phones, electricity and gas, automobiles, plumbing for water and sewage. And when we plotted these curves, we found that the inflection point of these curves was around the same time that triggered a big boom in productivity in the United States. So that led to a new hypothesis for us. In the previous industrial era, we needed 4 kinds of networks. You can't read them right here, but it's essentially health, energy, transportation, and telecommunications. And we repeated this study by collecting similar data for US, besides US, for China and India, and we found the same linkage. Now, could it be that our productivity problem today is that we haven't invented the new versions of these networks that are needed for today's times? And even if that is true, how would that matter for us, our network? The communications network is a bit different from these other networks. We carry bits. The other networks push physical stuff. And that brings us to the crux of this problem. It's the physical versus digital divide. Any country you look at, even the most developed country, you have a digital sector that is doing very well. The digital sector here takes 70% of the ICT investments, and its productivity is pretty good, 2.7% on average. But it's only 30% of the economy, and it employs only 25% of our workforce. The majority of the economy, 70%, is physical, and it employs 75% of the workforce, and its productivity is 1/4 that of the digital. So this is the real problem, the productivity of the physical sector. So that is the real promise of the 4th industrial revolution. Unless the 4th industrial revolution changes the productivity of the physical sector, we are not fulfilling the promise of ICT. So we have to begin with acknowledgement that we haven't done much with digitization. We have done the easy part. We have taken the low-hanging fruits. We have removed, wherever possible, in media, entertainment, financials, atoms, and replaced them by bits, and created the efficiency. But we cannot do that in the physical sector, what we eat, what we wear, what we drive, where we live. But we can augment those things with bits. And the real problem that we have to solve with the digital is how to control the physical, how to optimize the physical, how to remove waste in the physical. How do we do that? What does it mean for our network? It means that our network has a new purpose, not just to carry the bits for voice, messages, pictures of cats and dogs, or other entertainment stuff, but to do something more. our network should be able to understand the state of things that matter to us. And when I say things, for health, it could be our physiological state. For transportation, it could be state of the traffic. For manufacturing, it's a state of everything, from inventory to supply chain to the processes in the factory and so on. So the big purpose is to sense, analyze, optimize, and control. And to do that, the network needs 5G. That's why we need the reach of 5G, the higher mobility, higher performance, reliability, and security. Now, to achieve that, we'll have to bring two technologies together. And initially, they will appear to collide with each other. The ICT technology on the digital side and the operations technology on the physical side. They will collide because they will put demands on each other. They have been evolving separately so far. In ICT, our mobile networks have reliability of 4 nines. We'll have to go to 5 nines and 6 nines for industrial control. For interfaces, they will have to embrace standards so that there could be more interconnection. On ICT side, we have created services mostly for consumers and generic enterprise. We'll have to cater to the business process control type services. And OT has been very slow in evolving and adopting new technology. It will have to embrace the speed of ICT. When we do this, we'll create another new network that's needed for Industry 4.0. That's the manufacturing network. And when I say manufacturing, I include in that agriculture, mining, and so on. For end-to-end automation of a factory, the kind of use cases I've listed here show the range of performance requirements they will put on the network. And that's not going to be easy for today's network architecture. So we will need a new network architecture that will get the most out of 5G. It's a simplified vision for Nokia's Future X network architecture is shown here. At the bottom layer, we'll need the high-performance network, all kinds of access, wireless as well as fixed, using licensed as well as unlicensed spectrum, public and private networks, and the smart core. We'll also need a multi-cloud, a core cloud, metro cloud, edge cloud, to bring compute wherever it is needed. We will also need a digital value platforms. These are the platforms that will abstract out and aggregate the state of things that I talked about that network will gather and expose them through APIs for business applications to be developed. And of course, the business applications that are catered to the specific verticals to improve the efficiency in those sectors. So this brings us back to the past and the future. What I showed is in the past, different networks had to come together. In the past, it was health, energy, transportation, and communications. For future, it will be our new incarnation of the communications network, a smart one. But it won't be just doing what we have been doing better and faster. It will actually enable the other networks to become smarter by using the state and manipulating that state. So for our physiological state, smart health, smart energy for the more distributed energy generation with renewables and the microgrids, finding the state of demand and supply and matching that, so that's smart energy. Smart transportation, using all the sensors in our infrastructure as well as in the vehicles to improve the efficiency there. And the smart manufacturing, as I already talked about. So that is my claim, that we get this right with Industry 4.0, we solve a huge economic value creation problem. We get out of the productivity rut in which we have been stuck so far. So that's the opportunity for our industry. Thank you.